5.2 polynomials, their factors and zeros. We're going to be finding polynomials from solutions, from factors, and graphs, and going in the opposite directions if need be. All right, so the fundamental theorem of algebra states that every polynomial equation with a degree greater than 0 has at least one complex root. Okay, complex means that it can be either real or non-real. So a degree of a polynomial tells us the total number of zeros it has. Again, it could be real or non-real. And the non-real zeros always come in pairs. Any of those I things, imaginary answers, they always come in pairs. So if you've got one, you've got at least two. All right? So let's look at a couple examples. X cubed plus 2x squared plus x. If you graph this, you'll see that it only has one real solution, and real solutions are where it actually crosses the x-axis. All right, so it only crosses one time. If you zoomed in and out, you would see the whole picture, but as you can tell, it has one real solution, and it has a little curve right here hanging up in the axis, and that's going to be the non-real. So this one's going to have a total of 3 because this is a cubic. Cubics have at least a degree of 3, so that means at least 3 solutions, whether they're real or non-real. And we know for sure that there's one, so the other two have to be non-real. Okay? All right, the second example is 4x to the 4th power minus 3x squared plus 5x minus 6. Well, we're looking at this, and I tried to get a really good picture of this. This is not a super good, but it has this little curve right here because this is a quartic, and all the quartics have this W shape or M shape depending on if it's a negative coefficient. This one's positive, so that means that it is in the shape of a W. Both ends are going up. And right in here is going to be where there's some imaginary zeros. But we can tell there are at least two real solutions because it crosses the x-axis in two places. So if it has a degree of 4, that means that 4 total zeros, 2 of which we can see are real, and 2 of which we know have to be non-real. And then the last one is negative 2x to the 5th power minus 3x squared plus 8. Again, this one was really hard to get in there on the graph. There's going to be an extra little blip in here. I couldn't get it zoomed in really well so you could see it. But it is to the 5th power, so that means it's a degree of 5. And that means there are 5 total solutions, whether they are non-real or real. You won't be able to tell unless you look at your graph. This one only crosses one time, so that means that the other 4 are non-real. Okay, does that make sense? All right, so a lot of these you can tell by looking at the graph. You may have to zoom in and out, but the main thing is just remember if it has imaginary answers, it comes in pairs. So if you have 1, then you got to have 2. If you can see that there's an extra little blip, then it means that's an extra one. This one would have 2 right here, and this one would have 2 right here with this point right here, and then there's going to be another one right there. So that makes the 4. Okay? All right. Looking at the polynomial y is equal to x squared plus 2x minus 15. Okay, there's a lot of information in this section, a lot of vocab you've got to know. Looking at this, the highest degree of x is 2, so that means the whole polynomial has a degree of 2, which means there are 2 solutions, 2 roots, 2 zeros, whatever. Okay, they may be real or non-real. If we can factor this, which we can, remember factors of 15, that subtract to be 2, which would be 5 and 3, and then the 5 is going to be positive because it takes the sign that comes with the linear term. So then we get x plus 5 and x minus 3. These are the factors. And then you set those factors equal to 0, and you get your solutions to be negative 5 and 3. These are the solutions, or zeros, or roots of the polynomial. Okay? So those words, the terminology is super important that you understand what they want. They're going to ask you for factors. They will ask you for solutions. They will ask you for roots. or zeros or x-intercepts, you need to know what they're asking you for because it's written in a different way. They may give you a graph like this, which happens to be this particular polynomial graph, and you can see right there is two real solutions. So there are no imaginary ones in this particular polynomial. And you can see it crosses right there, -5 and 3, okay? If you were just to be given this graph, they may want you to go backwards and tell me what the factors are. So then you would have to do opposite of this, which would be +5, and opposite of this, which would be -3, and put that into this kind of format right here. Okay, factors look like this, okay? They're taking the opposite from what is here and putting it into a factored form, okay? So you take this and put it in the opposite way in parentheses, right? Then, if you need just to know the zeros, that is actually the point where it's crossing. So that would be -5 and 3. Okay, that is the zeros, the solutions, the roots. All three of those mean the same thing. X-intercepts are a location. They are a coordinate pair location of an x and a y. So if you told me what that location was, that would be -5, 0, and that would also be 3 zeros. Sometimes they will refer to these and just ask you for the x coordinate. And that's okay, but they'll say x-intercepts. You know, x-intercepts mean where it crosses the x-axis. Well, that also happens to be where it becomes 0. That also happens to be the solutions and the roots. Okay, so knowing the difference in these terms, because you're going to be writing these polynomials from a graph, like this one, or from factors, like these, or from zeros, like these. Depends on what they give you. You can go backwards and forwards from either point. Okay? So know those words. All right, multiple, zero, or multiplicity. Sounds crazy, but it's very, very simple. Multiple zero means that a factor is repeated more than once. Multiplicity is the number of times it's repeated. Okay? Very simply put. So what you'll do is you'll have an example like this one right here. X to the 5th power times the quantity of x minus 3 to the 4th power times the quantity of x plus 2 to the 3rd power times the quantity of x minus 1. And you're going to take each one of these pieces and set it equal to 0. So x to the 5th power set equal to 0 will just become x is 0. It has a multiplicity of 5, as that is how many times it is written. It would be x, 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 5. So x to the 5th power would be a multiplicity of 5. X minus 3 equals 0 will become x equals 3 when you solve that. That is the solution, the 0, the root. It had a multiplicity of 4. Okay? X plus 2 to the 3rd power when solved will be, the solution is x is equal to -2 with a multiplicity of 3. And then x minus 1 when solved will be x equals 1, and it only had a multiplicity of 1. It was only repeated one time. Now, what that means is when you have a graph, if you have an odd multiplicity, like this 5, that means that the graph will cross through that solution. Okay, goes right through that solution on your graph. An even multiplicity means that it's only going to touch it and kind of bounce off of it. So if you were looking at the graph above, if you had a graph of this, that would mean that the graph would actually cross through the 0, the 1, and the -2 because they all have an odd multiplicity, but it would just bounce off of 3. Okay, so in other words, if you had a graph, draw one, and say we have right here is 3, because this one says a multiplicity of an even number on 3, then it would just bounce off. So that's going to be right here, multiplicity of 4. So that means it's going to bounce off, where it'll go down and touch it and bounce off, not cross it. Whereas over here, where it says multiplicity of 0, it's actually going to go through the 0, like that. So it bounces off if it's even, and it goes through if it's an odd multiplicity. Okay? And we'll practice some more on those. The main thing is just understanding what happens, whether it's even or odd, if it's going to cross through or just bounce off. Relative max and min we talked about before. That's the values of the function at a turning point, and it can be the highest or lowest point, depending on whether it's a maximum or a minimum, and it may be more than one. So you could have more than one maximum, more than one minimum in a graph, depending on the degree of the graph. Think of the maximums as the top of the curves on a roller coaster. You're at the highest points of that roller coaster, okay? And then the minimums are the bottoms of those hills as you go all the way down right before you go back up to another hill. So the maximums are on the top of the hill, the minimums are on the bottom in the valley, kind of like a valley. All right, in this particular graph, this one right here, we have a maximum right here. Let me change color. We have a maximum right here, and we have another one right here. Those are the tops of the roller coaster ride, okay? It has to be a turning point. It cannot be this right here. That did not turn, okay? This cannot turn, did not turn, so it can't be anything. It's just the curves, like a parabola. All right, so those are your maximums right here. And the lowest points would be your mins, okay? And all you have to do is locate the actual coordinate for where that is. So at negative 1.5 and 3.5 is this first maximum right here. At this should say just 0.5. And mark it 3. At 0.5 and 1.5 is our maximum right here. Okay? And then our relative minimum would be right here at negative 0.5 and negative 1.5. And then also over here at 1.5 and negative 3.5. These are your mins. Okay? Max is the top of the hills of the roller coaster. Mins are the bottom. And you can find this in your calculator if you put the function into your y equals part of your graph and then graph it, and then you want to find the max and min. You hit second and then you hit trace, and then you're going to push, second trace, and either minimum is 3 and maximum is 4. Okay, so if I was going to pull this one up, let me go ahead and do that on my calculator and let you see what it looks like when I try to find those. Right, hold on. Alright, so I'm going to go and type this in. Hold on. Move. Nope, I didn't even put down the equation. I can make it. No. Let's do this one up here. Since we already got it up here, I'll go and type that in. Let's do x to the 5th power, parenthesis, x minus 3 to the 4th power, x plus 2 to the 3rd power, and then x minus 1 minus 1, and graph it. Alright, let's see if we can make that look a little bit better. Sometimes, whoops, zoom, square, let's see. Oh, that's not any better. Okay, hold on. Zoom. Go back to zoom 6. I always like to go back to the standard when I'm doing this so I can figure out which way I want to go. You can't really see anything like that. Zoom 9. Nope, that's not good. last option that I've got, unless I want to completely zoom in. All right. Still working. Okay. So there must be some imaginary things in here. All right. So it looks like this would probably be a good place to start. You hit second trace, and I'm thinking that's going to be a maximum, so that's going to be a 4. And you have to do left bound, right bound. We've done this in class. Oh. And move it over. You're going to have to be on this side of the curve and hit enter. And then you're going to have to be on the other side of the curve. See if this will work. I'm not sure if it's going to work the way I've got it zoomed, but we'll try. And a guess. All right, so that one's going to say a maximum at negative 4.68 and y is at negative 8.56. So you can do these using the second trace option. So you want to go above and use your second trace option, and your max and mins are in there. Okay, definitely want to practice doing that in class. So you'll be really good at finding them. They're not that hard. Sometimes when you have a graph that's this crazy, because this one is going to make a huge monster of a graph. It's harder to find, but a simpler one you would have no problem with. But that's what you do: second trace, and then you either use minimum or maximum to find your minimum or maximum. Okay. All right, and let's see if we have anything else on this one. Nope, I believe that was it. All right, so we will practice in class. Main thing is knowing the vocabulary in this section and being able to go backwards and forwards from factors to zeros, make your graph, and vice versa. So I'll see you in class. Have a good day.